We're going to find the direction angle of a vector. We have this vector 3i minus 4j. If you're not as familiar with vectors as a linear combination, that's the same as 3, negative 4 in component form. So we want to start by graphing the vector. It went right 3 and down 4. And then we want to make it into a triangle, so drop a perpendicular line to the x-axis. Or we could have drawn that triangle by tracing the path that the vector took, so going right 3 and down 4, and then connecting. So we have this triangle. Let's find alpha, the angle in the triangle closest to the origin. So the tangent of alpha is negative 4 over 3, opposite over adjacent. So then to find alpha, we can inverse tangent both sides. But that's not the direction angle. The direction angle is the angle from the positive x-axis in the positive direction to the vector. So that's going to be all the way to here. But we can use this angle that we found. Don't worry so much about the negative, that's just telling us the direction that the angle was going. That angle takes up 53 degrees of a circle, so let's subtract that angle from 360. So theta, or the direction angle, is going to be 306.87 degrees. A few more examples so you can see an example in every quadrant. If the vector was 3, 4, your triangle would look like this. It went right 3, up 4. You don't have to even label the triangle every time because you know that you're going to end up doing the inverse tangent of y over x, like we did here. Inverse tangent of negative 4 over 3, y over x. So if alpha is the angle in the triangle, that's going to be the same as the direction angle because positive x-axis to the vector is that same angle. And if you want to generalize that to all vectors in quadrant 1, theta, your direction angle, is always going to be equal to alpha, or whatever the angle was that you found inside your triangle. Looking at number 2, your triangle is going to look like this because we went left 3 and up 4. So now when you do inverse tangent of y over x, you get negative 53.13 degrees. But again, don't worry about the negative. It's taking up 53 degrees of space here. We want to find theta, which is positive x-axis to the vector in the positive direction. So it almost goes a full semicircle, but we have to take away this little angle. So if you want to generalize that for quadrant 2, your direction angle is always going to be 180 minus whatever angle that you found in the triangle, assuming that you're making that angle positive. Quadrant 3, we're going left and down, so it's going to be down here. So that'll be going in this direction. You don't use 270. This is going to be a semicircle plus this amount extra. So you need to do 180 plus 53.13. So for quadrant 3, your direction angle is always going to be 180 plus your angle. And example 4 is what we did in the last example. And for quadrant 4, theta is always going to be 360 minus your angle in the triangle.